So did we push stuff across the floor table?
Yeah.
All right. So
I don't know.
this actually, in some ways, it's simpler than the last example. In some ways, there's more stuff going on. So let's give an example. Tell me. So what did you all do?
We pushed it without letting go of it. We had a question because we thought it wasn't framed, whether we pushed it and let go of it or whether we constantly pushed it. And so we took it from the frame that we continually pushed, but there was it wasn't something we ever released.
Yep.
And at that, we said that we had no acceleration as long as we continued on in the same direction.
Okay. Okay. So let's review. So these guys pushed a book across the table. You've got a book. You're pushing it across the table. So that means there's some force here. And you said that you're pushing it at a steady velocity, steady rate. So, and what your conclusion was?
There was no acceleration except when we initially moved it.
Okay. Okay, well that's a good one. So there's a point where it stopped when you initially moved it, and then so there was
a push on it. We
Yeah.
decided that this was a pushing for it.
Yep.
We kept going with it.
Okay. So does everybody agree with that? No acceleration?
Yes.
Okay. So if there's no acceleration, what does that? What other thing can we conclude? Let's think about second law. If there's no acceleration, remember, so second law is that F equals ma.
There's no force.
Yep.
You know how no acceleration is push and don't let the object go.
Right, at a steady. So they're trying to keep it at a steady speed or a steady velocity.
Oh, okay.
Okay. So what does that tell us? If it's at a steady speed, it's at a steady velocity. Sometimes I've got to be careful about my own language. Okay, so I know that you guys don't necessarily have the Newton's laws memorized. The second law is there's no acceleration, there's no force. Somebody, that's a start. I think that we need to amend that, though. That's a good start. No net force. Does everybody agree with that?
So it would be like thinking about a car traveling at exactly 30 miles
Yep.
per hour, not adding any speed.
Correct.
There's no force.
Right, there's no net force in a car traveling down the road. That's an even better example because it's like, wow, there's no net force on that.
We said it's using cruise control.
Yeah.
Okay, so cruise control. So in this case, this looks like a net force to me. I mean, so we got a problem. Houston, we have a problem. What's that? Well, there's two ways we can get out of this problem. One is that there is an acceleration. What's another way to get out of this problem?
Friction.
Okay, great. So there's a claim that there's friction force. Does everybody agree with that?
Yeah.
What direction would that be in?
Left.
So along the bottom here, we've got a force. So I'm going to call this F. So I'm afraid I'm a physicist, so I like to write down little letters, little subscripts next to them. This is F of friction. What do we know about these two forces then? They cancel out. They're equal and opposite. If this thing's not accelerating, they must be equal and opposite. Let's talk about the car. What if this is a car? I'm using up a lot of paper.
It doesn't matter.
All right. If we're going down the road, this is a great example. This is an example brought up over here. We're going down the road at a constant velocity. What does that tell us?
Don't have to.
There's no acceleration.
No acceleration.
Frictional force between the asphalt and the tires.
There's the friction.
So you guys want me to put a force vector here?
Yes.
All right. What other force vectors are there? Air resistance. Is that the right direction for air resistance?
Down.
What?
Unless you're getting
Up,
unless you're
gravity,
getting the
normal.
And now don't you have the calendar?
Right, so the road, the road pushing up, so there's a bunch of these little guys down there. What's pushing it, it looks like we've got things going this way and this way. Well, I drew this, is there a force pushing forward?
Yeah.
Yeah, me. My wife's pushing against me.
There's some internal force there.
Yeah, so this gets a little confusing because that's an internal force. Where is the force propelling? So this is a little hard to grasp. But let's talk about where is the force being applied to this car that's pushing it forward?
On the axle. Yeah.
So what is actually pushing it forward?
The rotation.
There's turning the wheels, like something's cranking.
So it actually, so we're saying that there's something on the road, but is it the road? The road's pushing it forward, isn't it? Yeah.
Because if it wasn't on the road, the tires would just continue to
So
spin.
it turns out the road is actually pushing this car forward. I know that's not, you probably don't like that. But what's happening is the tires are pushing against the road, and Newton's third law tells us that the road is pushing back equal and opposite direction. So we'll try to wrap our heads around that one. We can talk about
The engine.
what else did I want to say about it. So I guess we're pretty much wrapped up here. But maybe we should make sure we understand this last example. This is a great example of a car on the road. Thinking about all the net forces on the car, and then thinking about. So this is a case where you have to look at the car and say there has to be a force external to the car that's pushing on it forward for it to be counteracting these forces. Where could that be coming from? The only place it can be coming from is the road. And the road is pushing on it because the car is pushing in the opposite direction. Yeah, it's like, right, the car cannot push itself forward. It has to push off. It has to push off the world.
Well, it's like, it's kind of like walking or like doing a moonwalk, for example. If you're doing Michael Jackson moonwalk, you have to push.
Yep. Yeah, exactly. Exactly. All right.
Summarize the big ideas for tonight.
Summarize the big ideas. You were about to say.
It's not a force.
All right. Summarizing the big ideas.
Anti-force.
So what did we learn tonight? I think there's important things that we talked about. I think some really great things came up today. We talked about Newton's 3 laws of motion, which is something you should look over and think about. And what I think the really interesting thing that came out of tonight's discussion is the concept of inertia and how it's a very difficult thing to get our head around. That inertia is not a force. The thing that's keeping an object moving through space, its tendency to move through space, is not a force. There's not a force keeping it moving through space. That's inertia. That's a property of material. And the other thing that we talked about tonight is how to speak precisely about motion, which is another important thing to practice. It takes practice. Believe me, it takes practice to speak precisely about it, and that helps you think precisely about it. I had concepts of speed, velocity, and acceleration. And I think this very simple example of a ball being thrown up in the air and the trajectory of it going up, slowing down, stopping, and coming back, thinking about the concepts of velocity, acceleration, force in that example will really go a long way to help you get these concepts straight. Alice, do you have other ideas you want to throw in there? Okay, great. Yes, sir.
Is inertia a unit?
Well, mass is in a sense inertia.
Okay.
And that's what mass is.